Today on Pilot's Discretion, we're joined by Robinson Helicopter CEO David Smith. He tells us about taking over a family business, the reality of eVTOL aircraft, and simulator myths. Pilot's Discretion starts right now. Hi pilots, I'm John Zimmerman, and thanks for listening to Pilot's Discretion from Sporties. Visit sporties.com/podcast for today's show links and access to our archives, where you can listen to all 100 plus episodes. Also, if you haven't heard our newest podcast yet, be sure to check out the Airfax podcast, the story behind the story. Every month, Airfax managing editor Eric Radke interviews a fascinating pilot to learn more about the people behind the incredible stories we publish. The first episode is out now, and it is a great one. Visit airfaxjournal.com/podcast to learn more. Today, I'm excited to have David Smith on the show. He is currently the president and CEO of Robinson Helicopter, the world's leading manufacturer of civilian helicopters. Before joining Robinson in 2024, he had an 18-year career at Textron, including as an engineer for Bell Helicopter and as CEO of True Simulation. He has hit the ground running at Robinson with a number of new product announcements, which we'll talk about. David, welcome to Pilot's Discretion.
Thanks, John. Looking forward to talking.
You are the first person not named Robinson to lead the company. So I'm curious how you take the reins at a family business, a large family business, but still one with a lot of family history and tradition. How do you take the reins there and move forward as you have, but without losing the essence of a company like that?
Well, I mean, one of the most important things that actually factored into getting me to join Robinson originally was it's a great story. It's a really fantastic American story, one where Frank, the founder, was able to see many things in the industry that he loved. He fell in love with helicopters earlier in his career when he was doing design work for actually Bell and others. But when he did a lot of that work, he always saw this opportunity and built his family around it. Really, a lot of the early work was done in a family house here in Southern California, and that gave this foundation early of involvement in the family business. And so when I took over for Kurt, who was Frank's son, that was clearly a big part of the DNA here, was how we both considered it a family business in the most basic sense, but also so many families are built off of Robinson products and built with the factory workers and all the folks who've been here 30 or 40 years now. So it's a great culture, and it's one that I think at the core of what we do, we want it to feel like a family. So our service centers and dealer network out there are an extension of our family. Even our suppliers, we have some great suppliers who've been with us for the entire ride. So 50 plus years. I don't think that happens very often, even in aerospace. So super exciting to be part of the family business here in Robinson.
Yeah, it's a great part of the aviation industry. I think maybe aviation is one of the last industries where that still happens. We've got a little bit of that at Sporties. Lots and lots of employees been with us 25, 35 years. And maybe it's just something about aviation that gets in your blood. But the other thing that impresses me about Robinson, and I did a factory tour there years ago, I was blown away by how integrated you are. It seems like hunks of metal come in one side of the factory and completed helicopters come out the other end. You're doing a whole lot more than just assembling parts made by subcontractors. I would guess that's an advantage in today's world of disrupted supply chains. Is that true?
Absolutely. I mean, since the pandemic, most of the industry talked about things like a downturn in the industry. And really what that reflected when you get down into the weeds was that they had difficulty securing the ingredients to build helicopters. And so, of course, that shows on the top line. The deliveries are less. But Robinson actually grew through the pandemic and had really great success. Both we had inventory on hand that we had wisely, my predecessor and the team that supported him had wisely invested in raw material inventory, some of the critical components like castings and forgings that really are big drivers elsewhere in the industry. They had the foresight to stay committed to their suppliers. And I think it reflects that earlier comment about the family business that they said to these small businesses that supply our raw materials, said, we want to set the production levels at what's economical for your operation. And we'll buy that every quarter of every year. And of course, there's shifts and changes as things grow and you want more. But generally, we wanted to keep our suppliers healthy. So they did that even through the pandemic. So we were buying and stacking up material through the pandemic and the early years when it was so still uncertain. but that allowed us to really rise quickly in these last couple of years. And so I think on the whole, we're not able to fully escape supply chain dependencies. Besides raw materials, I buy engines, I buy specialty fuel bladders for the crash-worthy fuel tanks, I buy avionics, and the selection of each of those vendors plays a heavy role in how we decide, what we're going to produce on a given year. And right now, we're building about 8 aircraft a week, and there's no way in the world we could do that with the supply chain sort of being distributed around the globe and highly fragile. What we saw in some of the other OEMs out there. So I like the foundation this has given us to grow and to expand, and even to take care of our existing fleet customers. We're really able to constantly produce parts that feed the existing operators out there. So a huge credible step that Frank took way at the beginning of the life of Robinson to say, no, we're not going to place little fiefdoms all over the globe to feed the supply chain here. We're going to make the commitment to make things, and that's really been a strong success for Robinson.
I suspect most airplane pilots don't appreciate the variety of operations that your helicopters take on. You have private owners, agricultural users, law enforcement, news gathering, tour operators. There's just all kinds of roles that helicopters fill. And these are hardworking machines, many of them. So how does that influence your design and support choices as you think about creating a helicopter that is going to have to fill so many different roles in so many different parts of the world?
Yeah, I think one of the things that's probably less known than our vertical integration, people know of us as a highly vertically integrated company, as you mentioned, but people don't know so much that we are probably the largest single component repair and overhaul organization in the industry as well. The 10,500 ships out in the world, when they reach their major overhaul event, which is anywhere from 2,000, 4,000 hours, some are at 2,200, some are at 4,400, we see these parts come back to us, primarily the drivetrain components, but some of the other components too that are parts of the clutch actuation system. Sometimes things like float bottles will return back to us for service and support. And so the model of being able to do the overhaul of components and having tight control over those here gives us a lot of really positive things. We see the fleet wear and tear, and if some unique mission is overloading parts in the fleet, we can adjust that and we can improve the design to accommodate that in future iterations. And the same thing for components that see really difficult environmental exposure. The best example is we see cases out today where the R44 has really carved a niche in the tuna spotting industry. So these used to be done with other products that are out of production now. And so they can buy now R44s brand new, put them on a boat for several months of the year, and it's one aircraft and it's mission critical. If you don't have the helicopter flying, hard to spot the schools of fish and be effective as a crew. So they use these as mission critical tools in their toolbox, but they get exposed to very, very difficult corrosive environments, very difficult sand and the blowing dust that comes from the decks of ships and things. And so these things also a lot of times will alight on water using these fixed pontoon floats. So they are in some of the most difficult environments really that we see. And when those parts come back to us, we learn a lot about how our corrosion protection systems are holding up or not. In some cases, that's led directly to improvements in the fleet performance and iterations in our design of the paint systems and the proper treatment of rotor blades and dynamic components. So it's a huge opportunity for us to get out there and see how customers use the aircraft and then iterate from there how to better serve the fleet going forward. So I think that's a huge advantage to us that most people serve, that's third parties that do that work for most of the competition. And they just miss that entire learning cycle from the fleet in most cases.
You certainly accelerated innovation in your short time at the helm. And probably the biggest news is the recent announcement of the R88, Robinson's largest helicopter to date. So who is the target customer for this new model? What do you envision this helicopter being used for?
Yeah, so in our fleet today, 3/4 of the operating fleet is overseas. So outside of the North American market that typically is a dominant general aviation market for a lot of competitors, we see that as this is a global product in the way that the Huey was a global product, particularly post-Vietnam. The various versions of the Huey product served in everything from support of border security to movement of people and relief goods. Certainly a lot of things that are part of utility lifting, heavy movement of industrial equipment and pumps and major cell towers, things like that are really big parts of the utility lift segment. So we see this as a really significant utility lifter. That is certainly going to be in 20 years' time. It'll be the dominant portion of the fleet and fleet hours for sure. But we know that also a lot of our private customers, those that do it sometimes as a personal carrier of people and things. In other cases, they use it as a small business where they're doing a little bit of utility lifting, maybe a little bit of tourism, maybe a little bit of contract services of one form or another. Those folks we expect to also be big buyers of the product. And so far, that's been the case. I mean, we went to market, out at Verticon about a month and a half ago now. And when we went and showed this to customers, we deliberately focused on our dealer network. We've got over 100 dealers around the world that are all extremely successful selling our 44s, 66s, and 22s. But we wanted to unveil this to them, share what this can do for growing their kind of portfolio of products. And so far, we've sold quite a few just through them. So not quite to 100 yet, but we're rolling in that sort of range now. And we haven't even talked really in depth with large fleet customers yet because we wanted to preserve what has been successful, kind of dance with the one that brought you. We've had a great run in the 52-year history of the company with our dealer network and expect that to be the bulk of the fleet sales that we'll do. But there's also going to be some customers that, buy dozens or hundreds of aircraft over time. They'll want to replace aircraft with the R88. And we expect some number of those customers to be signing orders over the next 6 to 9 months. And, we'll see how widespread the missions are for that. But there's definitely use cases in air medical, air tourism, where customers told us they cannot operate older aircraft that cost more to operate every single year. They need newer products certified to the latest amendments with the latest technology that's going to keep the aircraft operating smoothly and safely for years to come. And that is the R88.
And tell us about the single engine turbine. That's becoming more and more common in the airplane world, but I sense a lot of helicopter pilots still think 2 is better than 1. So why do you think 1's the right answer here?
I would say, I lived this in my previous life, at Textron, where there are missions that benefit from a second engine where the exposure of a auto rotation landing is in itself a high risk. So long distance oil and gas is a good example of that, where they're flying several hundred nautical miles off coast. You need a twin for that. Most of the missions, though, where twins have been adopted, honestly, they are because that's what the OEMs produced was more twins, so they sold more twins. And I think in a world where we have the combined pressures of engine supply is a challenge. It's my only challenge right now in my R66 line. I've got aircraft built right now without engines because I can't get enough of them. And I think the world is full of that. If you go talk to any of the OEMs, they're all short engines from all of the players. So it's not unique to one or the other. It's all throughout the industry. So my argument is, one, it's a constrained and sort of challenged thing to manufacture. That engines are tough. Second, it's an efficiency argument and a sustainability argument. In a world where we care about how much fuel we burn, in a world where these things are mission critical, and I'll tell you my stories about electric propulsion later. We're doing a lot of that, but reality is there's going to be a need to burn jet fuel for much longer and avgas as well for as long as we have to replace that with an unleaded option. We'll be burning fuel for a long time, and I think it is wise. It's smart for us to benefit from the technologies over the last 30 years that have made turbine engines so reliable. Most pilots that we talk to that tell us, I got to have a twin, I ask them, how many times have you had an engine failure? And their answer is almost always 0. And that's decades into their career. And I'd argue when you look at the statistics now, the single engine turbine capability has reached the point where we can argue that it's the right choice for the vehicle, right choice for the environment, right choice for the industry to utilize singles where they're appropriate and keep the twins focused on where they're necessary. And I think that's the best kind of combination of capabilities for everyone.
Another design feature on that R88 is the 2-bladed rotor system, which brings up a whole range of discussions that come into play with mast bumping and SFAR 73. And we can get really deep in the weeds here that I'll try to keep us from doing that. But at a high level, there's been some renewed interest in this topic with the tragic Long Ranger crash in New York recently, which may or may not have anything to do with mast bumping, but the topic appeared in the news again. And so let's go back to SFAR 73. It's requires special training for certain Robinson models. It's sparked by some early accidents in the R-22 many, many years ago now. It's become a fixture of helicopter training. If you learn to fly helicopters in R-22s, one of the first things you'll do is get that SFAR training and get that endorsement. So my question is, how does SFAR 73 look in today's world, especially as we think about the 44, the 66, the 88? These are very different products, obviously, but the SFAR was attached to the 44. So tell us where you think we are today and what value that has.
Sure. So first thing is the SFAR, I would argue, was a highly successful tool to confront what was an emerging challenge for general aviation in the early years of Robinson's development history. And Frank was a big proponent of the end result for the R-22 in particular, that folks needed additional awareness, particularly those that were transitioning out of high time fixed wing, airline roles or cargo freighter roles. And this was their next choice in hobbies, their next choice in things they wanted to do after they retired from those industries. And far too many people, were in those aircraft early, and they didn't have necessarily the nuanced understanding of the rotor and the rotor dynamics that really are part of the two-bladed rotor system. So low G mast bumping was a topic for sure in there, and then the low RPM rotor stall is another one that took a lot of lives. And I'd say that the statistics support that is not. That is something where pilot training, pilot awareness was one of the most essential ingredients in preventing that from taking lives in the future. And the data supports it now that those things were radically reduced. And we rarely even see those things as a part of a causal chain anymore. Even mast bumping is a diminishingly small number of aircraft that are exposed in the two-bladed aircraft fleets. And so we see that as being a diminishing overall piece of accident causes in the industry. And so, when people really get down to the weeds on it, though, I think the R-44, and this is something that our late vice president of engineering shared with me in his, the first year I was here, that he wished they had fought harder on the R-44, and he had success when the R-66 came out. That there was no need to include that in the SFAR because the rotor inertia and the rotor performance was basically dead on with where the other two-bladed rotor systems in the fleet were seen. So the Jet Ranger is the best example. It had the same fundamental auto rotation characteristics, slightly different overall performance, but very similar. And that reduced that risk of the low G mass bumping concern and also the low rotor inertia and RPM decay. All those things were factored into the 66 design. And so the 44, he wished he had fought harder because truly they made those same decisions in the 44 as a very similar rotor, very similar inertia characteristics, and very similar preservation of energy. So because of that, he said, look, there's an initiative now that has now gone through its final rule where the SFAR is going to be addressed over the next 5 years with a final complete incorporation of some kind into pilot training standards and the aircrewman standards. We'd expect that a large portion of it will become what is part of everyone going through their pilot training for a PPL and rotorcraft. And there is a high likelihood that we will no longer talk of it as an SFAR because it's set to expire at the end of the decade. And the end result we think will be the same benefits, which are people talk about the right topics on these light rotor aircraft, but you don't have to necessarily deal with the complexity of an SFAR and the complexity of all the endorsements that we do today. So we'll see how that evolves. But in my mind, it's been a success. It has saved a lot of lives, I think, and it has demonstrated that many things in aviation are about training, are about pilot decision making, and they require focus and an investment in the company. We've put a tremendous amount of resources. Frank himself taught the course and has a lot of material that he still put out there, taught the course in each of these topics with a great deal of passion. And I think that's been a focus for Robinson in our safety course. So we continue to deliver the safety course for both 22, 44, and 66, kind of as two different groups. But we keep making sure that customers are exposed to those topics with a lot of case history and walking through accidents so people can really understand how these things can happen relatively quickly. And there's no shortage of challenging topics in these things that we can walk through with customers in our safety course. So it's been a big focus for us and continues to be today.
That safety course is great. Anybody who flies Robinson helicopters and has not taken that, I'd encourage it. I did it years ago and just got a ton out of it. But in addition to the training, you all haven't been standing still on the aircraft. You somewhat recently launched the symmetrical horizontal stabilizer, which addresses to some extent the mast bumping. You've got some new autopilot products on the 66 and 88. Tell us about what you're doing from the aircraft side of it.
Sure. So there's really two topics there. One is the symmetrical stabilizer. So we over the last 10 years, we had particularly a lot of pressure in New Zealand because there was a rash of several mast bumping cases that occurred in extremely high winds, high turbulence, and high speed. And we saw those things as an unfortunate collision of a bunch of examples all within a short order. And my predecessor committed during that discussion to say, what more can we do? What more can be done to analyze and assess and simulate the dynamics of the aircraft? And really, his interest at the time was to really understand that, because he's not an engineer, he was a pilot, but not an engineer. And he spent a lot of time saying let's really put to bed the concerns people have about the rotor, because people focused on the rotor because it's different. It is better, and I'll argue better every day to folks. I'll explain why later if you'd like. But I say that he wanted to eliminate the topic of the rotor as a concern, but really understand what was causing these accidents physically. So really understand it. And so we engaged a number of universities here in the U.S. and a private third party that does advanced simulation for a lot of military applications and other things that gave them just immense simulation capability. They needed our insight on the rotor design and all the pieces of the mechanisms in the design that could be modeled and created in a physics-based simulation environment. So we did that. The simulations looked at everything. I mean, people ask all kinds of things. Well, what happens if you eliminate the coning hinge? Okay, well, we tried that. We looked at what happens if you can't the mast fairing, so you have some difference to offset some of the roll phenomena. We tried all kinds of things. Shifting the tail, changing the vertical fin, changing the tail rotor. All those things we looked at. The reality is, the thing that very quickly showed itself was that the roll phenomenon was coming from the horizontal stabilizer position in the previous design. So when someone gets into low G, again, outside the envelope, that low G phenomenon fairly quickly develops into a right roll. And the right roll is causal in the chain where people then put a response into it instinctively, particularly fixed wing pilots where their instinct is to correct and just sort of get the aircraft back to wings level. They quickly go into their sort of instinctive training, and they go left lateral, and that is what causes the mast bumping and mast contact, and then therefore typically the rotor flaps into part of structure and hits the tail or the cabin. So what we found was that we can effectively eliminate with some areas where people can still get into a roll, but very limited. That stabilizer shows side by side. Our flight test folks put it on the ship, demonstrated it, and it was basically a benign condition at that point. So the roll doesn't evolve, and the pilots are able to quickly reload the rotor, pull aft on a cyclic, and the entire chain doesn't happen. And so a highly effective tool to mitigate low G mast bumping. So for folks that fly in turbulence, fly light gross weight, fly in situations where they may have exposure to updrafts from mountain flying or whatever, these things are big savings and big improvements in the underlying safety of the product. So we've been putting those out at basically at our cost and trying to get our service centers and dealers to do as many modifications as possible. We probably got 20% of the fleet covered now, but that means there's 8,000 ships that need to get updated, and we're ready to do it. We've got lots of stabilizer kits ready for folks. So if any of the listeners don't have it on their ship, they should. I mean, 22, 44, and 66 are all approved everywhere on the planet except for China and England. And we're working quickly to get those approved as well. So that's step one. Get the basic aircraft to be a more sort of benign and give one more layer of protection. If somebody gets out of the envelope and gets into a spot where they shouldn't be, it gives them one more layer of protection. The secondary piece that we mentioned is in the final stage of certification with the R66. So we'd expect within the next 30 days to have approval of a 2-axis and 3-axis Garmin autopilot on the R66. And we've been testing and developing this for about a decade now. So we were kind of one of the first to work on this with Garmin years and years ago, but actually it was slowed down while we did the stabilizer project. And so now we're back to finishing the autopilot. But a big part of what we've added to the autopilot, Garmin makes a great system. They've added the additional features to mitigate low G mast bumping, primarily by when an aircraft gets into low G, it puts controls around how much lateral stick authority you have, and it cues you and tries to reload the rotor for you. So for a pilot that was concerned about low G, say a Vietnam era Huey pilot, and trained about how to best manage the low G in that context, the world has changed. This is generations of learning beyond, where we've now given pilots this additional layer of safety that they never had before. And so when you think about it, if we could conclusively eliminate that risk or fully mitigate mast bumping, two-bladed systems are more efficient. They're better at power, they're better at hover, they're better at auto rotation, and you have all the susceptibility of ground resonance that comes with multi-bladed rotors that adds elastomeric dampers and complexity in the landing gear systems. You eliminate all of that, and you can get a very safe, very robust, easy to pre-flight rotor system that costs less, weighs less, and is more energy efficient. Very hard to beat that. And for our global customers, those are the love languages that they live by is, can it be field supported? Can it be observed from the ground in fairly easy way to see that it's got all the right hardware in place? Those are things that make complex multi-bladed hubs very difficult to in service, keep them operating in Southeast Asia or in Central Africa. Those are difficult markets to support. So I think we've done some incredible things coming to market over the next several months. You'll see the R66 product coming out.
Yeah, that's exciting. We've seen that in the fixed wing world with the ESP product. This first came in Cirrus products, where same idea, using autopilots even when it's not engaged to give some envelope protection for pilots. And I think we've seen really successful things there. So I'm excited to see some of that in the helicopter world. David, let's take a quick break. And when we come back, I'm going to switch and talk about the world of eVTOLs a little bit. Hey pilots, let's be honest. Once you pass your check ride, flying isn't just about checklists and maneuvers. It's about making smart decisions and adjusting when things don't go as planned. That's where VFR and IFR Mastery from PilotWorkshops come in. Every month, you'll get brand new flying scenarios, one for VFR pilots and one for IFR pilots, designed to challenge your decision-making skills in a safe, risk-free environment. Led by PilotWorkshops' award-winning team of flight instructors, these scenarios focus on practical flying tips and real-world strategies that make you a more confident, more prepared pilot. Whether it's handling tricky weather, navigating unexpected airspace issues, or making tough go, no-go calls, Mastery helps sharpen the skills you actually use in the cockpit. It's more than just reading an article or watching a video. It's a multi-step, interactive experience that even includes a community section where you can talk with other pilots about their decision-making process. I've been a panelist for Mastery, and I can tell you it's one of the most educational and fun experiences of my aviation career. So I invite you to join thousands of other pilots who rely on these expert insights to stay sharp. Sign up for a free trial of VFR or IFR Mastery today at pilotworkshops.com and take your flying to the next level. That's pilotworkshops.com. Now, back to Pilot's Discretion. We are back with David Smith, who has been a vocal critic of some of the more pie-in-the-sky pronouncements from the Advanced Air Mobility, or AAM world. David, there's been lots of exciting mock-ups from startups over the last decade, but it seems to me that the shine's maybe come off recently. There's been some notable bankruptcies like Lilium. There's been some other companies missing targets. And I thought you said it well recently. You wrote, some people are, quote, trying to talk past physics. So where do you think this segment is headed in the medium term here? Is it all hype, or are there going to be some winners out of this?
So a couple of things. First, we are not just observers of this space. We're active participants. We've hosted quite a few of the eVTOL startup companies here at the factory and talked them through a lot of our recipe. We're trying to be generous with our scars, share our scars and learning, so that help them be successful. Because growing GA is a hard topic, and we need to grow GA and make it more attractive to kids that are coming out of school right now. So it is a topic that's near and dear to our heart. So we're going to do that in two fronts. We're going to help try to make sure that the winners in this race that they're pursuing of various new markets and new applications have some ammunition that we can offer them. That we are going to do that. But in parallel, we're also electrifying and developing sort of a roadmap for our products. Recently we flew a hydrogen-powered R44, and that's en route to a future certified hydrogen-powered R66. And I think we're going to offer those as competing alternatives to the stories that you hear out of distributed electric propulsion eVTOL. But I'll say that in the core of this industry, it's a lot of folks that fundamentally have never developed or certified any aviation product at all. That's the nature of most of the leadership in these companies. And because of that, you're going to get this sort of fulcrum and challenge of people putting a lot of emphasis on this in increasingly inflating expectations from investors for speed and for performance that in the end isn't going to yield. And there's physics reasons for that. I'll spare you the physics of it, but I'll just say that when we were saying similar to the topic of the single engine turbine topic earlier in the interview here, I'd say that truly the need for redundancy is overhyped. And I think rarely in our industry have we gone backwards in redundancy. Hyper redundancy, in the end, no matter how you look at it, will increase failure rates. And it may help with, similar to how a twin engine works on long-range helicopters, it may increase the mission reliability, the ability to get to destination, but it doesn't really help you much when you get there. And how do you get and turn the thing around and fly the other way? So truly, that's how oil and gas works today in the helicopter world. They have twin engine applications. They have an engine failure en route. They have the ability to go and land on an oil rig or divert to a shorter distance oil rig nearby. But then what do? They have to go and boat parts in. They have to fly in train technicians to do the installations and change things out. That's extremely expensive and can be borne only by oil and gas companies that produce tremendous amount of money for each of these rigs. So for us to look at a consumer-focused view, where you need to increase radically the number of failures in the fleet, is it doesn't make sense both on the physics front and on the economic front. Similarly, this challenge that we all face today, which is the trade of efficiency, which comes in the form of disk loading, a high disk loading, which is like V22. It's each of these eVTOLs is kind of in that range of a V22. You put a lot of power in to generate the thrust necessary to hover. And that was a trade-off in the V22 that was part of shipboard operation, packing it into an aircraft carrier. That concept, in this case, has led to this really kind of crazy, from an outsider view, that these will be so power hungry in a mission where you're constrained by battery technology, and that will both be in the pure capacity of them. Can they carry enough energy to get you to a useful range? But then secondarily, the way you stress these batteries out is you draw all of their capability and their capacity in a short period of time. That's the C rating. And these batteries have not been invented yet that will take the high C rating of hovering a very high disk loading product in the last lifetime of flying. They just don't exist. And so we've done our work. I mean, I hired a guy that came right out of eVTOL that leads my electrification work, and that was his experience in that space. And he came from Rivian and Tesla before that, knows what the investment was put into for their technology batteries, and it's not compatible. They're not the same thing. And so, I see the DEP world as trying to seize on 2 or 3 things that were all attractive in their own way. You see a lot of consumer drones. They use multiple propellers. You see, and they're very simple components and simple things, but also they're not flying mission critical stuff. They're not flying people. So it's that was an attractive oversimplification. Then the same thing on batteries. Oh, you see a lot of electrification in cars. We'll just throw those batteries in the air and it will work perfectly. It does not, and they're not the same missions or duty cycles. I liken it to people as when one of the eVTOL companies is prone to saying Tesla's in the sky. If that were the case, it would be the ludicrous mode launch capability of the Teslas for the entire flight, or at least for 2 huge phases, the beginning and the end of a flight, that destroy the batteries. And so they're not bound by physics, of course. They're bound by sort of what investors accept. And so when we look at it, we're going to solve what I think is the most important pressing challenge here, which is there's a need for the next generation of aviators to have solutions that offer lower emissions in the fleet, so hybridization. And then in the future, I do think some folks will want zero emissions, flying over national parks or very sensitive communities that really fight hard against any emissions at all. Okay, well, we will have solutions for those things, and we'll benefit from the fundamental architectural simplicity of the lightest disk loading rotors in the industry. We build very efficient vehicles, both from the rotor loading and power requirements and from the underlying fuselage weight that drives so much of the sort of how much these things weigh. And that's another point to highlight, that I use the example to folks of the Hummer EV, which is a hilarious example of EV gone crazy, which is, I drive a Tesla. I just got a nice Tesla that goes a long distance and is very simple to operate, low maintenance. So I believe in these things, but the Hummer EV is kind of a disaster of it's so heavy as a vehicle that you're not getting the benefits. And so a modern designed ICE engine, particularly one that has sort of the stop and go, engine idling capability that the modern cars have, is more energy efficient than the Hummer EV. And so what are we trying to do here? So I think when you get down to it, these are really heavy aircraft because they're trying to overcome all the challenges of the motor redundancy, the battery redundancy, this huge copper wires to feed the power. So I think truly we're going to have a hard time making this sale to any reasonable audience that this is an energy efficient solution to anything. So helicopters powered by hydrogen, powered by electric hybrid solutions will be, I think, a much better option. And the remaining issue that we have to go focus on as a helicopter industry is noise. We have not always taken that as a critical design parameter. Some of the folks in the European markets have, and I think we can do a lot more. And so my team is working on that with some of the designs around the 88 to try to drive better noise profiles out of our products in the years ahead. So that's kind of how I see this industry going. And investors, I think, will keep feeding this for a while because the unfortunate reality is once you're invested in something, you kind of start having blinders, and that bias creeps in. And my hope of all the things I hope for is we've got three critical resources that the eVTOL industry is hurting right now, which is regulatory capacity, engineering capacity, and supplier capacity. Each of those is being divided across a whole bunch of startups that will likely not make it, and they're fighting topics in rulemaking that are delaying critical rulemaking in other areas. And so, to me, I look at it as there's only so many people who can put pen to paper at the sort of the right rulemaking side of the FAA or EASA for that matter, and they're being drawn into these discussions around VTOL that may never turn into a product or a market. And so I think as an industry, we should question that of whether this is the best use of our resources, or in 10 years, are we going to regret all this? And I suspect we will.
That's a great summary of a very complicated topic and where we stand today. I share some of your skepticism on the technical challenges. I think there's also, even if those are surmounted somehow, I think there are challenges around economics and the business model, not to mention customer acceptance and neighborhood landing pads and all kinds of things like that. So definitely a complicated topic that we'll be following for years to come, I suspect. Now, David, we always end Pilot's Discretion with a lightning round called Ready to Copy. I'll ask some rapid fire questions on a wide range of topics, and you read back with a quick answer. Are you ready to copy?
You bet.
Flight training has been booming for the last 5 years or so, but a lot of that energy has gone into the airline route. So what's your quick pitch for someone to pursue a career as a helicopter pilot?
Saving lives is best done in a helicopter. And, if you are motivated by the food chain and keeping people well fed around the world, if you were interested in doing things that build infrastructure for the future, if you're interested in things that, get people out of dangerous situations, keep the public safe, helicopters are the best tool for that, no question.
How about manufacturing and maintenance and even design? What is a simple thing we could do to attract new people to the aviation industry and these jobs?
Well, in light of the accident that happened this last week there in New York, I think one of the most difficult things is to have trusted people that can speak without hype, without hyperbole, without the unfortunate things people get drawn into about fear. I think we need more people that can speak confidently about the great things our industry does to help keep people safe, but also talk plainly about the inherent risks of flying at low speeds, at low altitudes, near wires, near buildings, near the water. I think those are all things that are real. And so we need to have better spokespeople in this industry speak up about the truths and the realities of it. There are solutions to all problems. And I welcome as many smart people to come join our industry to go and confront the challenges. But they are such necessary tools that it is worth our time. So we need all those people to row together.
When designing an aircraft, would you rather have better performance or better dispatch reliability?
So dispatch reliability builds the market, man. There's no question about it. I think, to beat ground alternatives or boat alternatives, it doesn't take the fastest vehicle on the lot, but if you can't keep it in the air and the customers can't depend on it, they're still going to buy a boat to back you up. So instead, you do what we do, and that's why the tuna fishing is a great example. They buy one Robinson helicopter and they carry it on their boat, and they can't live without it. And it works every season. And I think that's dispatch reliability in its core. It's not the fastest, maybe not the prettiest, but it is extremely dependable. Gets up and goes.
What is your favorite feature on the new R88?
Ooh, I love the utility of both the sliding doors and the aft fold-down door, because I just envision, my son is of the age where, so I'm not a pilot because I have epilepsy, but my son will probably be a pilot. And I can imagine us going in heli-camping in an 88 with the back bed rolled down and the sliding doors open, and we're, just sleeping in the back. And I can see that being just an incredible private aviation story that so few people get to enjoy. We want to make that a more common future state for folks to aspire to or to benefit from. And I think accessible, affordable vertical lift is such a great capability.
That sounds fantastic. You were deeply involved in designing the Bell 505. So let's switch over to Bell World. What's something about that helicopter that is interesting that you might not see from the outside? What's sort of a hidden design detail there?
Yeah, I think one of the most interesting things about the whole design was we focused on trying to give folks an affordable utility option. So flat floor is a huge advantage in that. But one of the things we had to do was try to reduce the cost for components that people, otherwise wouldn't pay the price for. And so through some really clever engineers, found a replacement for the hydraulic pump on the 206 family. The 206 Jet Ranger family has the gearbox that feeds the power for that aircraft. The hydraulic pump on that was like a $10,000+ component at the cost line, like really expensive part. And for us, we said that's just too much. So we went and found components that would meet the performance without the cost. We found something out of the industrial supply chain, used primarily in cherry pickers, for bucket work and doing wires and such. That kind of a technology find took some time to both get installed, get tested, get qualified, but it was a really good example of how you get good engineers focused on function, not on pedigree of the sort of the origin. And honestly, I visited that factory. It's in the center part of Germany, and that factory produces incredibly high quality components because they make so many of them. They can't afford to have poor quality in any respect. So it's a lot of automation and a lot of high volume production that I thought was really incredible. So it was just one example, but I'll tell you, that's to piggyback about how Robinson works. Robinson's built off of that thinking that we will find the best product, whether it comes out of automotive or industrial or consumer goods or whatever, to serve our customers' needs and our underlying performance. But I think on the 505, that was a really great story of saving like 95% cost. That's the scale of what we saved on that, 95%. So great engineering work there.
You spent some time running the simulator company. So what is a myth about simulators you'd like to bust?
Yeah, so I think, and we're starting to see it more and more now, that people think that there's like simisms that are enduring forever. And so the generation of sims that people were trained on 20, 30 years ago are not today's sims. Things have changed in terms of processor power, the ability for us to do complex physical phenomenon. Like we did a simulator for water dropping. It's in Milan now. It teaches the CL-415 as a firefighting ship. And it can accurately simulate the complex aerodynamic phenomenon around fires, temperature gradients and various updrafts and downdrafts and things. All of that can be simulated today. And it's not like we're doing sort of a brute force way of doing it, but the actual physics can be modeled and can be turned into a real-time closed-loop simulation. So you can really do the things that we've always dreamed about. We were also demonstrating things like complex scenarios where you're trying to train winch operators in the back while you have pilots operating another simulator, synchronized motion between a front seat crew that's trying to coordinate search and rescue modes with a backseat crew that operates the winch. That's tricky. And today we burn jet fuel to train those guys, most cases. But the technology's there, and there's a lot of those actually they're demonstrating it at some of the industry trade shows now. So, I think what people were constrained in simulation 20, 30 years ago is not reality anymore. And unfortunately, if people go train, they're actually training likely on a 20-year-old sim. So new simulators is really important that benefit from all the new hardware and software. So we're super excited. And actually for Robinson, the future for simulation is great. We see a really significant opportunity to take simulation and distribute it around the globe and make it extremely affordable, like Robinson always does, so we can push training scenarios that are based on field reports and field experience. I didn't mention it, but we have cockpit cameras now that are on all of our aircraft leaving the factory. Those cameras, we get videos, tons of videos from them of both non-fatal near misses and fatalities, both of which have their instructional purpose. And you can put those into a simulator now directly and show people what that pilot felt, saw, vibration they felt, all that stuff. So simulators have come a really long way in a short period of time, like everything around us, all the consumer products that have benefited from this. So I think that the myth is that something like regulated simulation is only capable of doing certain things and certain capabilities. That's changing. It is so close to the real thing and can be improved even further. And so we're excited about simulation in the years ahead.
All right, David, our last question is always the same. You have one final flight. We want to know, what are you flying and where are you going?
So today, R66, and I think I'll go north along the coast here because it's just such a beautiful part of the world. We fly a decent amount that direction for all kinds of reasons. Our partners up at Garmin are in the north of here, and gives us a reason to get that direction routinely. I think it's something about flying along a coast that makes helicopter flying that much more interesting. And given Los Angeles' huge activities on the beaches and huge activities in the sky, you'll see some great airplanes, you'll see some military aircraft, you'll see a ton of beautiful topography of hills and green. So I think the Southern California coast is just hard to beat.
David, thanks for being on the podcast.
Thanks, John. I really appreciate it.
Thanks for listening to Pilot's Discretion, brought to you by Sporties, training and equipping pilots worldwide for over 60 years. For more episodes and today's show links, visit sporties.com/podcast. I'm John Zimmerman. We'll see you next time on Pilot's Discretion.